Well, good morning, good evening, good afternoon to you, wherever you are joining from. My name is Hjalmar Gislason, and I'm going to host this conversation about the AI calculation problem, which is something that's dear and close to my heart. I have with me a fantastic guest. I'm going to share some slides here. There we go. I have a great guest with me today, Donald Farmer. He's a principal at Treehive Strategy. Donald is a data and analyst strategist with over 35 years of experience in the field. He's a principal at Treehive Strategy and advises global clients on innovation, analytics, and AI. Donald's career includes leadership roles at Microsoft and Click, where he pioneered significant product designs, working on products like Power BI and ClickSense. Now, I'm reading this out, but Donald is also one of the smartest and most interesting people I know, a former colleague of mine at Click, and a man that I'm proud to call my friend. So I think you are in for an interesting conversation here today. But first, a couple of housekeeping notes. We will do a roughly 30-minute conversation where we talk about what the AI calculation problem is, some of the potential solutions to it, and how to mitigate the problem. Then we'll move into Q&A. If you have questions during our conversation, please put them into the Q&A section in the webinar. And then my colleagues are on the chat, so for any comments about anything practical or anything else, you can reach them in the chat as well. In the chat, they will also be sharing some links to things that we mentioned during our conversation, so keep an eye out for that as well. So without further ado, let's just dive in. What is the problem? So what we say that we have quite a few people joining here from all over the world to listen into something that we call the AI calculation problem. Now, what is the problem? This is something that is, like I said, close to my heart, and actually a problem that I am actively working on solving with solutions that we have built at Grid. And it is something that there's a rising awareness of, as well as kind of people get deeper and deeper into their LLM implementations. I think maybe it's best illustrated with a simple example. I'll do a quick example, and then I'll hand it over to Donald to talk a little bit about the problem and maybe some examples as well. But here, this is taken from ChatGPT. This is a screenshot I did just a few hours ago. I've asked ChatGPT to multiply two numbers. So there are two numbers that have 3 digits in them, and it looks simple enough and it looks convincing enough. ChatGPT will confidently tell us that 123.456 times 654.321 is 80,790, and then a lot of decimals. It's very accurate. This very accurate in its reply there. Now, if I put these same numbers into a calculator, like a proper, well, not a proper, but an Apple calculator, what I see is slightly different. So it turns out that the result is actually 80,779 with a lot of significant digits thereafter. So as you can see, this is not the same number. Now, it's in the ballpark, so maybe it's not so bad, or what? What do you say, Donald?
Depends what you're using it for, but it's giving certainly a false sense of accuracy, isn't it?
It is, and if we'd imagine like a chain of calculations going on, and each of them has an error like this.
Exactly, yeah, it could really build up. And there's a couple of things to notice here that I think are important. You said it's in the ballpark, which is even more annoying, actually. Because why isn't it getting it right? And how is it that it's getting it approximately right? You can understand if it couldn't do it and it just got the answer completely wrong, or it can't even do this because it's a language model, not a calculation model. But it's close, which is actually, in a sense, rather confusing. And you might think that there's two things going on. One, you might think that there's a problem in the calculation, like a Pentium chip having problems with floating point numbers, or so it's a problem in the calculation engine, or or the alternative would be that it doesn't understand how to do a calculation. But either way, it's actually rather irritating. The other thing that's going on is, if you notice your calculator is using Scandinavian notation,
All
not
right.
using a decimal point, but using a comma. Um, that would confuse it even more
Right.
if you actually used if you had that format in the language model.
Exactly. Yeah. So absolutely. And maybe one more thing to note, and this is the same. Like, no, this is the hallucination problem. It's not kind of only relevant to doing math, but there is no doubt here. This is just this is stated as a fact, and there is nothing here to give us a sense that we might want to double check the number. And this is something that I've actually been surprised because standing so close to developments in AI and so on, I have been aware this is kind of a major problem with AI. But as AI goes from like cutting edge and kind of tech savvy early adopters to the mainstream, a lot of people are just unaware that these models can be inaccurate at all. So they may end up trusting these things blindly. Recently, I was talking to a customer that was using ChatGPT for simple math, and they didn't even realize that it could be wrong.
Right. Yeah, exactly. Yeah. And that's a real problem. I mean, I can't do that calculation in my head. And as you say, it's approximately right, which is actually, there are circumstances if you just wanted the ballpark, but don't do your taxes with it.
No, exactly, exactly. And this is something that we see that now obviously LLMs are have done have they have opened up the world of the computer to language. They are now allow us to instruct computers in our own natural language instead of us having to learn a programming language or use purpose-built tools to do various things, and that is fantastic. But they are still where they really shine is working with language, like writing text, helping us brainstorm, because that's something we do with language and so on. But when it comes to these things and kind of maybe making use of external systems or diving into facts and calculations, I think many people are realizing in their LLM journeys that there are things to be desired there. I know you did some experimentation with
Right.
different models and different solutions when it came to kind of why don't you just walk us through what you did there?
Yeah, I mean, talk about doing my taxes with it. This was a calculation that I had to do for my UK pension, and the government told me, gave me this table in a letter, in a printed letter, telling me the contributions that I had to make in order to catch up with my pension contributions because I've been living in the US for so long. And so I thought, well, I've got to type in all of these numbers and add them up. Why don't I just scan this in and give it to an LLM and ask the LLM to do it? And I thought this would be pretty straightforward. And I realized that, first of all, it might not be able to scan it, but in fact, the scanning was extremely accurate. Claude, I used Anthropic Claude, and it did a really good job of understanding the problem. It understood that this was a table. It understood that these were tax years. It understood that I wanted to add up this column. It added up the column for me, and it got it wrong. And
Right.
it got the calculation wrong. It understood everything about what I was trying to do, but it couldn't do the calculation right. And I called this post I made about the thinking styles because I tried it with three different systems. I tried it with Claude, with Anthropic, and with DeepSeek, and they all got it wrong in different ways. That was the interesting thing. They all
Hmm.
got it wrong, and but the way in which they got it wrong was different. Partly because they took different approaches. Sometimes they tried to say, well, several of these numbers look the same, so we'll add up all those first, and then we'll put the whole thing together. Then they tried to add each column, add each line separately. Others just sort of didn't really tell me how they were doing it. They just gave me an answer. But the important thing here was that it looked very convincing. If I hadn't actually double checked, then it would have added up this column and I would just have accepted it.
Right.
Even when I did ask it to double check, it then went through a thinking process, told me what it was doing, but still got the answer wrong in the end. And it was sort of fascinating. The one which came closest to getting it right gave me a correct answer, except it then gave me 8 decimal places, I think, and a number at the end of that, when in fact this can only be added up to 2 decimal places. So there was some very, very strange things going on, and each system got it wrong in different ways.
It's very, very interesting. And I believe that the link to your blog post you wrote up about this is already in the chat for people that want to check
Okay,
that out.
thank you.
So if we kind of move on, like there are examples of like these are not all calculation examples. Some of them are, and some of them have kind of calculations in them that are part of the problem. These are just a few things that I kind of picked up from the internet about where AI has gone wrong with consequences in the real world already. So, an old one from something from early last year, where Air Canada was ordered to pay a customer that was misled by a chatbot. That was actually a pricing question, but it had more to do with policy than anything else. Uh, you know, Gemini or Google put an ad. The Super Bowl ad had a fact problem that had to do with like God. I think Gouda being 50 to 60% of the consumed cheese in the world, which is something that Gemini would state. And kind of the other things here, like I actually just found the one in the bottom left there, which is like just a small cleaning business in Australia that used a chatbot to write a quote to a customer. And it ended up costing him $2,000 because it was quoting, it had all the information, but it just ended up quoting it wrong, quoting kind of the wrong
Ooh.
item prices. And then in addition to that, adding them up wrongly, but he blindly trusted it and sent out the quote, so he had to honor it. So this is like, it's the early days. These are all external facing use cases. Most of the things that people are doing with LLMs is internal, and we probably don't hear about mistakes or consequences that have happened there. But this is what do we make of this, Donald?
Well, so you made a very important point that some of these have to do with policy, not just with calculation, but it's very related to calculation because although the Air Canada issue, for example, was because there was a policy about particular fares, I think they were bereavement fares. If somebody had died, you could get a discount to go to the funeral. The prankster tricking GM is a kind of policy. You shouldn't be able to argue or
Mhm.
negotiate down the price of a truck to $1. But what's happening here is that people are using a language model, and built into that is part of a process which involves calculation and numbers. And those are, if you like, different paradigms, different ways of thinking. And it's not just that the language model makes mistakes in policies, but the way in which we're used to thinking about policies, especially as they relate to calculations, deals, numbers, that sort of thing. We expect the numeric part of that to be accurate, and
Mhm.
we expect the language part. In fact, if you look at a policy, you look at an invoice, most of what you see on the front page of an invoice is the numbers. You turn it over and you have the small print, which is the policy
Right.
on the back. We literally divide our business into language questions and numeric questions. The
Yeah.
numeric questions on the front of the invoice, the language questions on the back. What's happening here is when you're using an LLM, for example, for customer service, those very different ways of doing business are getting confused with each other.
Yeah, exactly. And in some ways, these are mistakes that are different from what a human would make. Like even
Yeah,
without any written guidelines, a human would probably never negotiate a Chevy Tahoe down to a single dollar. So there are also kind of the
exactly.
guidelines. You want to, yeah, when you implement these systems, you want to make sure that there are guidelines in place that they cannot, like, they calculate correctly, but they also calculate within the business constraints that you want to put in place. Um,
Yes, exactly.
and here, like I just like this chart so much. So this is a comparison chart of people are trying. One way that people are trying to solve this problem is training LLMs to do math better. And there are models that are specifically trained to do math. The best ones are now. Well, this is actually from late last year, but the best model is now 85 is correct 85.16% of the time with doing math with 5-digit numbers. Now, we have had pocket calculators for 60 years now, probably, that do
Yep.
5-digit computations correct 100% of the time. And this indicates to me that maybe we are outsourcing the problem to the wrong type of program in this case.
We are, and yeah, it's a very interesting problem, isn't it? That the different models have such different qualities of performance as well.
Yeah, exactly. And Anthropic has actually been doing some very interesting research. This is one of the things that I find fascinating about LLMs, that even the people building them, they don't know how they work. They know roughly how they're
Right.
architected, but they don't know how they come to the conclusions they have come. But there's been a series of articles coming out of Anthropic these last few weeks where they have started kind of introspecting and investigating what is going on inside of the model as it's thinking through problems. And this one caught my eye here. So this is, again, a very simple math problem. It's adding up two numbers, 36 and 59. And, I won't bore the audience with reading through all of this, but on the one hand, it's kind of doing very much like a human, adding up the last two numbers. Yeah, this must, 5 must be the last number. Then on the other hand, it's kind of doing rough calculations of the overall number and then saying, oh, it's somewhere in the range from 88 to 97. Probably, not quite how a human would think, but we would probably, oh, it's between 90 and 100, and then it has to end with a 5. It's 95. So it's actually interesting how human-like this thought process is, but it also points to, like, just like we won't run entire business models in our head in a sub-second second computation time, you neither want a human nor an LLM model to be doing this. You want a calculation algorithm or a calculation engine to be doing it, right?
Absolutely, and something very important about the way in which human beings do this is that we have learned a series of we've learned a series of algorithms ourselves to do these calculations. When you have to do a number like this, you don't calculate it to a well, you do calculate it, but you don't reason about it. You
Right.
calculate it using using an algorithm that you've been taught at school and
Exactly.
which you have practiced many, many times. And the difference between a human being doing that algorithm and that calculation and an LLM is that what the LLM is doing here is reasoning about the answer, not calculating the answer,
Yeah.
which is a very different process.
Absolutely. And then maybe kind of finally on the problem side, before we start moving into the solutions, this is also not a problem that's going away. So, and I think maybe kind of the word here. So this is a paper that came out about maybe 3 months ago about, hallucination being an innate limitation of large language models. You can make them much bigger, you can make them much more complex, but hallucination is actually a part of how they work. Or in other words, they are non-deterministic, which is, again, very different from other algorithms we are used to. So I know you've thought about that quite a lot.
Yeah, this is very important, that the non-deterministic nature of a large language model, because well, people will often tell you that it's only a predictive model, which is true. It's primarily predicting results rather than calculating a result. So it's looking for the most likely answer, and as a result of that, to a certain extent, the hallucination is going to be inevitable. Now, we might think of this, by the way, as a problem, and of course, when it comes to calculation, it is a problem. But it's also part of the value of a large language model.
Yeah.
The fact that a large language model is not is not giving us, in a sense, precise answers is exactly the reason that it's so valuable for processing language. So it's really, yes, it's an innate limitation, but it's an innate limitation which arises from the power of the models. And I think that's really important. We might want to correct this, but we have to correct it in a way which works with the value of a large language model, as opposed to breaking the value of a large language model in order to fix this problem.
Yeah, no, I've even heard people suggest that if we were able to come up with a large language model without hallucinations, it would lose all of its creativity and thereby interpretation powers of human language. So, that is like
Yeah, exactly.
that's the magic. That is what we got out of them. So in some ways, like very nice kind of segue into talking about the solution. we should absolutely, and what we have enabled here is we have, once again, we have, for the first time in computer history, we have a way to communicate to our computers in our language. That doesn't mean that we have to outsource every job that we previously used our computers to do to these language models. They are more, they can be an interface. We can use the language as an interface instead of pointing and clicking or writing computer code. But behind the scenes, many of the things that we want the computer to do will still be facts and calculations, and those are probably better outsourced to databases and calculation engines and kind of traditional algorithms. So let's talk about solutions a little bit here. I'll go again and kind of, here is the same problem as before. This is what we started off with, the simple math problem. Now, the thing is, even without leaving ChatGPT, I can prompt it to use code to calculate it. So I simply tell it to use code to calculate the result. And now it comes to the right conclusion. If I was in ChatGPT, I could press the arrow there and it would show me the code that it used to calculate that, which is very simple. It's just multiplying two numbers. But if we remember the calculation result from before, this is actually the correct result. Now, what's happening here? Why didn't it do this right away?
Yeah, well, what's happening here, of course, is that it is, when you ask it to use code, it is actually now issuing a calculation, not reasoning about it. The first time it was reasoning about it, now it's calculating it, and it's generating that code. The same thing happens if you ask it to make a prediction. It'll go and write Python code to go and run an algorithm and do a prediction. So it knows at this point, because you've specifically asked it to look up something, to use an external engine from itself in order to do that calculation. That's very, very important.
Exactly. And speaking of that, like LLMs need assistants to do facts and calculations. And one of the ways to do that, like we've seen, language models, they're good at language. So text was the first modality we saw, but then we've seen images and audio and video and all sorts of other things. But one of the things that maybe is the most impactful thing that LLMs have brought to the world as of yet is their ability to write code. Code is a language, computer code is just one form of language, and there's a lot of that language in the training data for most of these LLMs. So it's quite good at writing code. And by giving the LLM environments a runtime engine, in the case of ChatGPT, for example, a Python engine that can then run the code, it can work with code. It can even work with tabular data, small tabular data sets, by writing code to actually add up the numbers or kind of do other calculations on the tabular data. And as long as it's using the runtime engine, at least the calculations will be deterministic and the calculations will be correct as long as it gets the problem right.
This is very important. And I also want to make one additional point here, which is not just a question of, well, it can't do a calculation. But in the business world, there are some specific types of calculations which have to be centrally sanctioned in an organization. A really good example of that would be the calculation of something like profit margin.
Right.
That there's no simple calculation of profit margin. I don't just mean that the calculation is complex. I also mean that there are business rules about that, which may depend on your tax jurisdictions and all sort of things like that go into that calculation. And one of the big problems we have in business is that very often calculations like that are done differently in different departments, which is why we end up with things like data warehouses and OLAP systems in order to provide a centralized definition of that calculation. So it's not just a question of getting the arithmetic right. That's like, even if the LLMs could do arithmetic, they would still need to be able to call out to systems in order to do very specific types of sanctioned, centralized KPIs and calculations for business.
Very important point. And one of the things here is that a lot of people using so even though the calculations will be correct, meaning deterministically correct, if you run code to do them, a lot of the users of these LLMs, they are unable to read code, so they can't say if it's doing the right thing. They can't open it up and reason through it. However, within businesses, we do have systems. You mentioned OLAP. We also have spreadsheets. We have databases. We have data warehouses where we have definitions and calculations and and embedded things that where people that are experts in these things have encoded these things. So that brings us to the other way that you can assist the LLM, and that
Yeah.
is with tool calls or tool use, function calls. These are called different things in different systems, but essentially the ability to call on external systems, typically through a RESTful API, to outsource, well, to get information that you can then build the language answer on. So that might be an API that calls out to a database engine. You mentioned OLAP before. It might also be an API that reaches out to the web to get the weather or currency exchange information or something that's more real time. That is, another problem with the LLMs, that they are fairly slow to internalize new information about the world, because the training is such a long and expensive process that they don't have the latest information. Or in case of what we are solving for at Grid, it can call out to a spreadsheet engine where you have put in the spreadsheets, the calculations that have been written by the finance experts or the operational experts or whoever has been doing that in the same way as they've been doing that for 20, 30, 40 years. And
Right.
the language of spreadsheet is a very well known one. So here you can essentially get the best of both worlds. You can keep interacting with your systems using natural language, which lowers the barrier for users inside of your organization or inside of your user base, but still rely on the sanctioned, well understood, deterministic, and verifiable ways to do calculations or lookups.
Right, and very importantly, everybody has spreadsheets. I mean, this is I think this is really critical. The example I gave in my blog was a building contractor, a real world building contractor who does calculations of the amount of concrete they need for
Yeah.
laying a floor or something. And that calculation is not, it's a little simple in the sense that you just calculate the volume, but there are also things like you have to add 10% because there's always some waste and so on. But they already have that calculation. They've already done it. They've been using it for years. And now they want to do something like send a quotation or ask for a quotation. And they would love to use an LLM for that, but they need to be able to link to that calculation in their spreadsheet. And they don't have a big database. They don't have code. They don't have any of those things, but they do have a lot of spreadsheets that they use for this today.
Exactly. And just like you need a runtime engine for Python to run Python code, you need a runtime engine for spreadsheets to run spreadsheet formulas. So, on the one hand, you have tabular data, and there are, even, Python, for example, can deal with tabular data sets. But as soon as there's a formula in there somewhere, you need something that can read that formula, can run that formula, and can run the chain of calculations that
Yeah.
would typically reside in a spreadsheet model.
Yeah, exactly. It's not just the answer. There's got to be an engine there that actually does that.
Yeah, exactly. So, and on that note, just to tout our own horn a little bit, we will be hosting another webinar, another online event next week, where we will have a hands-on demo of what we are doing at Grid, which is essentially connecting the world of LLMs to the world of spreadsheets. So these are the times, and the link to that registration is in the chat. I'll kind of leave the commercialization at that, and maybe we just move into Q&A, unless there are any last points you would like to add here, Donald.
Well, I think the key thing for me is that this link to spreadsheet is particularly important because people understand spreadsheet models. And this is something which, we think of the spreadsheet just as a calculation engine. Spreadsheets also contain models of your business. So you are calling out not just to something to do a calculation, you are actually calling out to a modeling environment. And I think there's a great deal of value in that as well.
Absolutely. So yeah, we do have a couple of questions in the Q&A.
Okay.
Let's dive in here. Yeah, let's go for this one here. So, do you think LLMs will eventually evolve to be able to do these calculations accurately? I guess without assistance.
Well, I mean, it's a good question in the sense that I want to come back to what I said earlier, that in some ways, the I don't want that to happen at the expense of the LLM's creativity and non-deterministic values. So I think part of the problem an LLM is going to have is always going to be able to identify where that calculation is. But I also want to come back to the other point I made, that it's not just a question of being able to do the arithmetic. We have business definitions of how particular calculations are done. I mean, a great example of one I was just working on yesterday, and it was a difficult calculation, was the average sales per business day, not per day, but per business day of a previous time period. And that time period could have been week, month, quarter, year, financial year. That's a business definition. That's not something an LLM is going to understand. That's a business definition that has to be right every time for tax reporting purposes. Any LLM in the future is still going to have to be able to call out to that predefined calculation of the way of doing it. So it's not just a question of being able to do the arithmetic. It's also being able to interface with the business model, which is why I did want to make that point at the end, that the spreadsheet is not just a calculation engine, it's a business modeling environment as well.
Yeah, exactly. And actually, we didn't mention this, but one of the interesting things, and this is I mentioned the Anthropic research about how their models do math. One of the things that they point out there is that the way they actually do the math, and then the way they will explain how they did it if they're asked about that, are not the same. So they're actually making up
Right.
an explanation after the fact, like some humans do. But that's actually also very important, because how can you then audit, even if it's correct? How can you audit? How can you rely on it being deterministically correct?
Right. Yeah, they can't explain its explanation.
Right, exactly. Because it isn't really, like, when it's asked to give an explanation, it just generates an explanation, not the explanation. It doesn't go back and think about how did I do that and explain that.
Yeah, I mean, it's very important to remember that an LLM, when it generates a right answer or a wrong answer, it's the same process in both cases. It's not that something's gone wrong. It's
Right,
just
right.
that in some cases it happens to generate right answers, in some cases it happens to generate wrong answers.
Yeah, and I mean these are statistical models, so that's what they would do. Like, they're
Exactly.
they're fuzzy. They will be maybe somewhere often around the answer. And also, like, working with numbers like language, the way these models work is that they will tokenize the strings. They will tokenize human language into small
Right.
bits of language. And essentially, when they come across a number, if you don't do anything about it, they will just start kind of making tokens out of parts of the number, and then use the same logic on that as they do on words and parts of words. So that is interesting. Here's another one. Yeah, well, I'll give this one to you first, but I have an opinion as well. Does this impact the future of spreadsheets? Will it change how we use them or how we build them?
Well, I think it does, of course. It probably changes the future of everything. And if you think of spreadsheets as including code, well understood, but
Hmm.
spreadsheet formulas are still formulas, and they are still a form of code, and therefore you can generate that code. You can generate spreadsheet formulas, and you can already see that built into certain spreadsheets. But the interesting thing about the spreadsheet is that it has survived for so very long.
Hmm.
It is that model turns out to be a very, very good model of how human beings think about business models. And I know you've blogged about this in the past, Hjalmar, that you know s- proto spreadsheets go back almost literally thousands of years. This
Hmm.
idea of laying out information in a grid is a very, very powerful way of thinking about information, and that is not going to change.
No, exactly. And on my opinion on this, so I think this will, I mean, this is already changing spreadsheets to some extent. I think that the most common way that AI and spreadsheets come together is that people are using LLMs to help them write spreadsheet formulas, just like they are using them, to write other code. And they're actually very good at that, because they have a lot of examples of individual formulas. However, they can't write an entire model, because as opposed to opposed to other computer code that get executed linearly, line by line. There's this two-dimensional relationship, or sometimes three-dimensional relationship between values that live in cells in a spreadsheet. And again, you need a spreadsheet engine to do that. It's not that it's any harder or any different in many ways than other code. It's just that you need to interpret it differently and then execute it differently from code that you can execute line by line. The other thing, so we have been very focused on the consumption of spreadsheets because our thesis has been so just like what you're doing with your LLMs right now, you're feeding them with all your best text documents. To be able to help with writing marketing copy and, drafting landing pages for your web or ad copy or something like that. You put in your brand guidelines, you put in some of your, best blog posts and well-prepared content. Similarly, there is a lot of content, especially inside of a business, that already resides in spreadsheets. So making that accessible using natural language has been kind of the first order of business for us. So essentially, it's as easy to connect your spreadsheets and make them available to an LLM as it is to make your text documents. But I do think that we will see maybe larger leaps when the generation that is growing up now and kind of is also growing to learn how to kind of work AI first. So they will go to an AI chat environment or agent for almost any task they do. When somebody grows up in that environment or is really used to that environment, is tasked with, let's say, making their first business model, they want, now I'm going to learn Excel, or now I'm going to learn how to use Google Sheets. They will type into their chat environment, can you help me make a business plan where I can ask some what if questions and do kind of some planning? Spreadsheets will be the natural outcome of that, but by then we will have to have taught LLMs how to also generate these models. Now, I think they can be super helpful with that, just like any other code. But that is something that I look forward to bridge in the future. And I think actually it may be the first time in a while we might see a paradigm change in how spreadsheets get created. But I still think that the two-dimensional grid, again, it's been around for thousands of years, will be the way we want to verify it, read through it, and rationalize it.
Yeah, absolutely.
Very good. So here's one more question. Are you concerned about the fact that OpenAI and its competitors don't seem to have a business model that is likely to ever become profitable? Unlike normal software as a service businesses, every extra user and every new prompt costs them a lot more energy, water, and money. Now, maybe this is a little bit outside the scope of what we are talking about here, but do you want to try to tackle it?
Well, it is a little bit outside the scope, but on the other hand, I think it's an important question because we're going to be living in an LLM world. I think we are seeing the costs. We're not quite seeing the costs come down just now, but we are seeing greater and greater efficiencies in the model.
Yeah.
And in the business model of these companies. So I think this solves itself. When I first started working in AI, and I mean back in the 1980s, we were working with things like Prolog and Lisp. The assumption was you just need to throw more processing power and you need to throw more compute, and we'll solve all these problems. And that failed in the 1980s. The approach nowadays of we're going to build all these data centers, we're going to build all these power generation systems to drive the data centers, that will probably also not be the solution. It'll be another breakthrough in another class of models that are more efficient that will do it.
Mm-hmm.
So maybe it's not linear from LLMs, maybe it's another generation of models, but I think this solves itself in the long run.
I tend to agree. What this made me think of, though, is here's another thing we haven't mentioned: the overhead. Like if we go back to the Anthropic slide about the thinking how LLM actually does math, the overhead of adding up these two numbers by reasoning through a large neural network and kind of doing all the calculations, all the floating point calculations that go into coming to the conclusion of that the result of adding up these two numbers is 95 is I'll go out on a limb here and say it's probably 10,000 times more power that goes into that calculation than into just calculating these two numbers using an algorithm.
Yeah, but we're human beings and we can do it powered by 3 hamburgers a day. So
Right.
computationally, this is a solvable problem,
Yeah, right. Exactly. Very good. So we are out of time, and I think we have answered most of the questions in the Q&A. The recording
Right.
will be made available after we adjourn here. And again, thank you, Donald, for being such a great guest and all your insights. And I'll see you soon.
Thank you very much. Thank you.